In this video, we're going to look at how to multiply two matrices. So we're going to see this via an example. So to start off with, we have two matrices A, 1, 2, 3, 4, and B equals 5, 6, 7, 8. Okay, so if we were asked to work out A, B, that means these two matrices multiplied, A times B. 1, 2, 3, 4, 5, 6, 7, 8. Okay. And how are we going to do this? Well, our answer is also going to be a matrix, and answer is also going to be a matrix. And in order to get the element that goes in sort of this first row, first column of my answer, so row 1, column 1, I need to multiply the let's say the first row of A, so this row, by the first column of B. So I'm going to do the first row of A with the first column of B, and that's going to give me the first row and first column of my answer. So how do I multiply the first row of A by the first column of B? Well, I do it sort of step by step. I have to work from left to right on A and top to bottom on B. So you just get used to doing this. To work this out, it's 1 times 5 plus 2 times 7. 1 times 5 plus 2 times 7. Okay, now for my row 1, column 2 of my answer matrix, I need to look at row 1 of A and column 2. So now the 6, 8 column. So the 6, 8 column. So now I'm going to look at this 1, 2 row with the 6, 8 column. So I get 1 times 6 plus 2 times 8. Okay. So now I've done the first row of A with each column of B. I do the same for the second row of A. So now I do row 2, column 1. That would be row 2 is now 3 times 5 plus 4 times 7. And I do row 2, column 2. So it's 3 times 4 plus, 3 times 6 plus 4 times 8. Okay, and now I just work out all of these numbers for my final matrix. So 1 times 5 plus 2 times 7 is 19. 1 times 6 plus 2 times 8 is 22. 3 times 5 plus 4 times 7 is 43. And 3 times 6 plus 4 times 8 is 50. There we go. I've worked out A, B. 19, 43, 19, 22, 43, 50. Okay, let's do the same, but rather than A, B, let's see if we can work out B, A. So BA is equal to 5, 6, 7, 8 multiplied by 1, 2, 3, 4. Okay. So again, I'm going to do first row times first column. So 5 times 1 plus 6 times 3. Now I'm going to do first row, second column. 5 times 2 plus 6 times 4. Okay. Second row, first column. 7 times 1 plus 8 times 3. Second row, second column. 7 times 2 plus 8 times 4. Okay, and let's just work these out. I get 23. 10 plus I get 34. I get 31 and 46. Okay, so this is important. This answer BA was not the same as AB. So AB is not equal to BA in general. And this is a key factor of matrix multiplication. The order matters. AB and BA are not in general the same. Okay, let's just look at a little bit more matrix multiplication. Here so far we've only looked at 2 by 2 square matrices, but you can actually multiply other matrices that aren't square, and they also don't have to have, well, let's just clear this. So you can multiply 2 matrices as long as the columns of first matrix, I say columns, number of columns of first matrix equals the number of rows of the second matrix. So for example, we can multiply matrices that look like this. If the first one had 3 columns and 2 rows, then we could multiply that with a 3 by 3 matrix, because the number of columns of the first matrix is 3, and that's equal to the number of rows of the second matrix, which is also 3. So this works. If, however, I tried to do something like, let's say, here's a 3 by 3 matrix, and I tried to multiply that by a 2 by 3 matrix, now the number of columns of the first matrix is 3, but the number of rows of the second matrix is only 2. So we cannot do this multiplication because these two matrices, this doesn't work. Indeed, the general rule is if you have a what's called an m by n matrix. So what does that mean? That means it's m rows and n columns, and you have then you can multiply it by an n by p matrix. Well, an n by p matrix has n rows and p columns, and that works because we have the columns of the first matrix n is equal to the rows of the second matrix, also n, and if I do this multiplication, I'll end up with an m by p matrix. So it will have m rows and p columns. So that's a useful sort of idea to remember, because then we know what the dimensions or the size of our final matrix after a matrix multiplication will be. So let's do an example of this. Let's say so let's have another multiplication example. Let's try 1, 2, 3, 4, 5, 6 multiplied by this 1, 0, 0, 1. Now, remember, our final matrix is going to have the same number of rows as my first matrix. So it's going to have 3 rows, and it's going to have the same number of columns as my second matrix. So it's going to have 2 columns. So I know actually that my answer will take this form with 2 columns and 3 rows. Let's actually work this out. So again, the method is the same. We're going to work across the first row with the first column. So I get 1 times 1 plus 2 times 0. Then we're going to do the first row with the second column. 1 times 0 plus 2 times 1. Okay. Now I'm going to do the second row with the first column. 3 times 1 plus 4 times 0. Second row, second column. 3 times 0 plus 4 times 1. And now third row, first column. 5 times 1 plus 6 times 0. Third row, second column. 5 times 0 plus 6 times 1. Okay, and if I work this out, you end up with 1, 2, 3, 4, 5, 6. And this is quite interesting because we actually end up with the same matrix that we started with. And this is a known result because what we did was we multiplied by a special matrix. We multiplied by this matrix 1, 0, 0, 1. And that's known as the identity matrix, or the two-dimensional identity matrix, I or I2 but two-dimensional. And if you ever multiply a matrix by this identity matrix, you sort of end up with the same matrix. So that's why when I multiply 1, 2, 3, 4, 5, 6 by this identity matrix, I still got 1, 2, 3, 4, 5, 6.